forget. All right, and we'll continue on. All right.
The test is open from midnight until midnight on Saturday.
Okay. Yeah, I tried to access it the other day, and I forgot they can't access it until. So.
Tonight at 11:55, I think. So if you want to stay up till 11:55,
no, I'm okay. I'm okay. Okay. Let me get you some page notes again.
Yeah. So what I did last time was I wrote down all the lesson summaries because it has the photos in it.
Oh, that's smart. Look through all the lessons. All right. Okay, let's get started. Oh, wait, just kidding. Hold on. I have to log into SBS.
Usually, like, we have a desktop at our house, and usually that's what I use for this.
Oh, okay.
But we just downloaded it. My house is so it's weird. So we just downloaded it on here last night, so hopefully it works all the time.
I wasn't going to open this up because walking from my apartment to here, it would have just not worked. So there's no point.
Very finicky.
Yeah.
First time I had no idea how to use it. I was like how to get on there.
Gosh, tell me about it.
Bring it on campus.
It's so weird. There's another desktop on your computer. It's fine. Well, the first two we can answer.
Yeah, most of them you don't need.
Oh, wonderful.
Most of them are numbers, which is more confusing for me because they're not complex. I can do the numbers. Okay.
Okay, the first one, the 90% confidence interval, I always get it confused. I get it wrong every single time. So it's A, right?
Yeah.
Okay.
90% confident. Remember, because
okay.
The answer has the
word in it. Okay. I can remember that.
Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go no-go stimulus in males differs from that of females. The researchers randomly selected 20 females and 15 males. The go no-go stimulus requires the student to respond to a particular stimulus and not to respond to the other stimulus. Use this information to answer questions 2 and 3. The researchers decided to construct a confidence interval, determine the difference between means of significance, determine whether the confidence interval is reliable. They create QQ plots of both random samples and choose their approximate results. Are the requirements for completing a confidence interval satisfied? Y or Y not? Okay, so the distribution of the mean for each sample is normal, since the research can apply the simple limit theorem, or the distribution of mean for each sample is normal since the data has been determined to be normal.
Okay, that part again. It's
A.
So,
Here's my thing.
because it doesn't say that it's. Oh, just kidding.
Yeah, the QQ plot.
And it does say that it's approximately normal, so.
Yeah, I think it would be the QQ plot because I want to know about the simple limit theorem is because they're testing males and females separately, and there's not 30 people in two groups. Okay.
Fair enough. So. I didn't see the approximately normal, so I think it says it's normal.
Yeah, and they said they use QQ plots, and why else would you use QQ plots?
Yeah, true.
Okay, I think it's
Okay, of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Confidence interval when mu, for mu when standard deviation is known, confidence interval for mu when standard deviation is unknown, confidence interval for the mean of the differences using dependent samples, and confidence interval for the differences in mean using independent samples. For this experiment, mean of differences, wouldn't that be?
Yeah, that's what I said for independent samples. Right?
Yeah.
Because we don't know who's in the male group, I know who's in the female
group. Group, yeah. I would say independent.
Cool. A researcher is interested in estimating savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confident interval for the mean savings account 4402.084 and 4142.75. Which of the following will produce a confidence interval with smaller margin of error than this 95% confidence interval? And I said B, obtain the balance of the 90 bank customers, right? Those are 30. So the first one is obtain it of only 10, because 10 are more likely to be more uniform than 30.
Mm-hmm.
And then B is commuted to 99 confidence interval rather than 95.
Yeah.
So that would make it bigger, and the 10 one would make it bigger too, right? Because it's less people, and this formula is on the square root of.
Bigger.
Yeah. So
Okay.
B.
Yeah. Okay. A factory makes propeller drive shafts for ships. The quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 dry shafts made at the factory, measures their length, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean of the shaft. So, that goes back to that original one, right? To find the z-score.
The z-score is the margin of error, because I know it's the one where we times it by 1.96.
Wait, what is the 1.96?
That's the 95%.
Oh.
Okay, a confidence interval is 1.96 times standard deviation. Oh, that's what I was doing wrong. Okay.
Were you doing the margin of error? Or
No, what I was doing was the z-score formula, and so it's like, okay, it's 1,000 divided by 2 over the square root of 4, which is also 2. So it's going to be 1, and then it's, okay.
That makes no sense.
This makes so much more sense. So 1.96 times 1, so 1.96. So that's the right.
Wait, where do you get the 1?
2 divided by the square root of 4. So
oh, okay.
1,000. Yeah, okay, and this is the answer. A is actually the answer that I put it in a confidence interval called calculator, and that's the answer that I got. I just couldn't remember.
Okay, yeah. I didn't do that part, so I will trust your judgment. Okay. Ready?
Mm-hmm.
Okay. Do you want me to read it or do you want?
Oh, I can read it.
Oh, okay.
To assess the accuracy of the laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of 9 times and the mean of the weight repeated. Suppose the scale reading for normal distributors with unknown mean and standard deviation sigma equals 0.01 grams. How large should n be? The 95 confidence interval for mu, margin of error of plus or minus 0.0001. Quote.
Okay.
Okay, so we're supposed to use this formula. N equals
The z-score.
I don't think that's the z-score in
really?
this one. Isn't it the yeah, z represents the calculated z-score corresponding to a particular confidence level. So that's the 1.96 to 95%.
So we use 1.96 times standard deviation. 0.01 over, it'd be 1250, right? Is that what
Or you get 1250.
I was just kidding. Hold on. 0.0001. I was looking at the way wrong, and we were like, wait a second, what?
Yeah, it's
You're
like way up.
Yeah.
I have an actual calculator today. I forgot to borrow.
I was like, oh, you know what? I got 38,416.
Okay, I probably had a decimal place in the wrong. Most of point in the wrong place because I got.
You got the same numbers.
I got 38.4.16.
Oh,
so
okay. Okay, let's see. Okay. Do you have a quiz for this one too?
It's the exact same question
Oh,
because we never get to see the answer.
got you. Are you ready for the next one?
Yes.
Oh, mine does that all the time.
Darn.
I hate it.
We don't need it yet, so I'll just bring it back up when I need it.
Okay. The mean area of the several thousand apartments in a new development is advertised to be 1,250 square feet. That's where I got the 1,250. I was looking at the wrong problem.
That makes a lot more sense.
Okay, I was like, wait a second, I don't remember. Okay. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis are maybe A, right?
Yeah.
Yeah, less than.
The statistical tested hypothesis. We say the test is significant.
See, I know.
At the level of significance, if A equals 0.05, the p-value is less than A is smaller, the p-value is larger than A. So it's less than?
Yeah, because when it's when it's smaller than the p-value, we fail to reject.
We reject.
I mean, yeah, that's what I meant.
Yeah.
That is what I meant. Whoa. And then that means we have sufficient evidence. So, yeah.
Cool.
Okay. A group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample standard deviations are nearly equal. Can they use a NOVA hypothesis test to answer their question? Yes, it is enough that the data are bell-shaped and no outliers and sample deviations are nearly equal. Yes, they have a total of 60 GPAs, and also they can apply this to alert them. No, they do not have enough data. No, they do not know the true standard deviations of each sample. I think it's a no.
It's going to be a NOVA stuff. So data need to be normally distributed in each group. Oh, so we can't use central here.
So I would.
The standard deviation is not more than double the smallest standard deviation.
I'd say it. Man, my allergies. I went running this afternoon and I just can't breathe.
I don't feel like it's false because they don't know the true standard deviation. So it says it's the sample. Yeah, because that's why you're running it. It's the sample standard deviation.
Yeah.
Both those are nearly equal, so that can't be the right answer.
Do you mean?
Yeah.
Okay.
Is it enough that they're bell-shaped? Because doesn't something have to be normal to be bell-shaped?
Yeah, something has to be normal. Because it goes like, yeah.
Would A be right?
Because GPAs from an anonymous random sample of these questions throw me off because the data is not actually there, so it's like, it could be A. It is enough that the data are bell-shaped with no outliers and sample standard deviations are equal. Yeah.
Either A or C.
And I was saying I don't know if it's like a trick question because there's no data there. If it's like you don't have enough data.
Yeah, but I feel like we've had one before that has that view.
Let's see. Let's go back to the environment first.
That's just the recap, actually. Like,
Okay. Oh, looks familiar. Whoa. Okay, that was Tuesdays, right?
yeah. Did you notice that one of the homework this weekend was exactly the same? as the group meeting last Tuesday.
Yeah. I like got on and I was like, wait a second. It did. Okay. Okay, the data is normally distributed, which is bell-shaped, so that's true. The variances are equal for each group. The requirement is checked by examining standard deviations. If the deviations are close together, then the variances as well. That sounds like A. Yeah, I would say
Okay. I hate, like, usually we can check our answers.
A. No.
So now we just have to, like, plug in. I'm so nervous about this test. Because,
this is just a quiz.
yeah, I'm nervous about the test because test grades count for 60% of our grades.
I'm the worst test taker in the world.
And I've determined that to get an A, I need to get a minimum of 95 on every test. Even if I get 100 on everything else.
Are you straight A student? Like,
yep.
Okay.
And if I do it this semester, I get 4.0. My GPA here will be a 3.96. So I will qualify for free tuition. If I don't get a 4.0, I'll qualify for half tuition. So I'm like, I need a 4.0, but I can't do it. And I checked class statistics, and the highest grade on that was a 91.4. Okay, sorry.
Okay, you're good.
A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that the average time after survival time after diagnosis is the same for the new treatment as the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the null hypothesis would be rejected as clinical practice against the struggle. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with particular type of cancer. The researcher has committed type 1 error, committed type 2 error, used the wrong level of significance, or used the significance wrong. So if we have type 1 and type 2 error, all
Type 1, I think, is when you reject and you fail to reject.
Yeah, reject when she fails to reject. And that's what she did, right? She rejected the null. The null was what it was. Yeah.
Type 1 error?
Yeah, okay.
Okay, if the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? By reducing type 1, we also reduce type 2. The relationship between two probabilities is how the study set up. There is no specific relationship. By reducing the probability of type 1, we increase the probability of type 2. Pretty sure they were the opposite ones.
I know this is in.
Yeah, it was. If I remember correctly, I think it went back and forth. Like when one went down, the other went up.
Yeah, I think you were right. Okay, if you somehow reduce the probability of committing a type 1 error, it increases the probability of committing a type 2 error.
So that one is D.
I knew it was in the homework. So I knew I got it wrong.
Next.
Oh, the nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams mean and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of the cigarettes is 1.5. The measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis and 5% levels. You conclude that you should. Yeah, I didn't do this one.
You didn't do this one?
No, this one.
Okay.
I don't know if I did this. B4, right? And then put it into the applet. Here's the probability.
Yeah.
I'm going to come out in a while.
I know. ideas?
Right? No, I'm just
Oh, okay.
doing the formulas.
You know, we'll look at it.
It's the mean we found minus the mu divided by the standard deviation divided by the square root of the sample size, right?
Yeah.
Okay.
You got it?
Yeah, 1.5 minus 1.53 divided by 0.17 divided by the square root of 100. So that gives me 1.41.
And 1.41. And we got 0.1585.
0.1585.
0.1585 is the key.
And that's 0.1585. Yeah. Okay, so that would mean that we would fail our job, right?
For the 0.05, yeah. Above it, so fail to reject. Yeah. Okay. You look at the mean number of hours worked per wages per week by male students and female students. You'd like to take a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Is the matched pairs test the same as the sample t-test?
Yeah, the Medicare is the one
Can
where
we do
those,
that?
yeah, because they're dependent.
Okay.
An educator is interested in academic achievement by males and females with similar academic skills. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother sister pairs when they are next to each other in physical order. Should she use a hypothesis based on independent or dependent samples?
It would be dependent, right?
Dependent?
Yeah, because
They're pairs.
they're in order
Yeah.
to. The sister's academic achievement depends in some degree of her brother's. We select the brother to compare to his academic achievement for the sister.
That would make sense.
What, D?
Yeah, right?
Um,
If you select, if I
Well,
select your brother, I
actually,
have
hold
to select you.
yeah, but hold on, like,
Okay.
that, wait, when it might be A.
Okay.
The brother and sister are separate people who make their own choices. Does the people's academic skills have it influence on each other?
See, because the way I was thinking about it is that because in order to select your sister, you have to select the brother.
Okay. Okay.
Because knowing which brothers are in group one determines which brothers will be in group two.
Yeah.
I know your brother's in the test, I know you'll have to
Okay. Yeah, D then.
think.
Okay.
A soil collect and carry out the inferential procedure for each set of problems. Okay, this is where we start. So, I'm going to go ahead and turn that up. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. Dissolved organic carbon molecules are an important part of an ecosystem and help plants thus process organic compounds. The researcher would like to construct a 95% model to the mean dissolved organic carbon level in the system. Open the file and draw the file dissolved organic carbon. Use information to answer questions 15. So of the four types of compounds listed below, which one is appropriate? I said confidence level for mu that sigma is unknown.
I don't remember answering it. Hold on. Yeah. Which of the following is a 95% confidence interval for these data? Plug it in. Are we doing just a one sample t-test, right?
Yeah.
Okay, 11.160 and 15.21.
That's what I got too.
Good. So, which is D?
Yeah.
A simple or a random sample of Hummers for sale in Los Angeles and New York were taken from listings at Cars.com and want to know if there's a difference in mean listing prices between Hummers for sale. Okay. Create a 95% confidence interval for the two different of mean listing prices between the two cities. Also not filed.
So that one we want to do confidence for the different people. Independent.
Yeah. Oh my gosh, that is so much. Yeah.
Gee, she's busy. I don't have to go.
Yeah, that'd be
Oh,
yeah. Okay. Which numbers are we copying?
You're going to use the prices and the city. Oh, that's how you do it. You open into the spelling copy paste.
Yeah. How do you do it?
I log into iLearn on VMware. Or I've just discovered now you can copy and paste the textbook website.
Oh, really?
It'll open up.
Yeah, it was just the default on my computer when I opened it up. I was just like, would you like to open it up? And I'm like, no. And I'm just like, okay. You have to change that little thingy
Yeah,
again.
you have to have that.
Oh. Okay. And then, what did we decide to do?
Independent.
Jesus, right? Oh.
This is my group. So that's the right one.
Oh, okay. So I put
You put 1 and 2. It's really good.
easy enough. Okay, what is it asking us?
The confidence.
About negative 769.74. The 5,000.
Yeah, and they round up the number because you can't have like
Half.
yeah. So it's A.
Okay. Where'd I go? Okay. I remember in high school, my professor told me he's like you always round up, but we're like why? He's like, can you have half a person? No, you can't. You have to have the whole person.
That's a good way to think of it.
So,
Alright.
okay.
So many studies suggest research between exercise and healthy bones. Exercise just to bones causes them to be stronger. One study examined the effects of jumping on the bone density of growing rats. There were 3 groups, rats selected at random for each of the 3 groups. A control with no jumping, a low jump group, the jump height was 30 centimeters, and a high jump group, 6 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats was measured. The rats were selected at random into 3 groups. Researchers would like to perform a hypothesis test to determine if the mean levels of bone density are different between the 3 different groups of rats listed above. Use the level sufficient of 0.05, open the data file, exercise bone density. So what is the correct hypothesis test situation and the ANOVA form of this?
Oh. Okay, we said ANOVA.
And we're going to calculate the temperature.
Oh. I did not copy right.
No.
Okay, there we go. Okay.
You would automatically code it.
Okay, what is it asking?
The calculate the test. Yeah.
7.9.
Yep, that's what I do. It gives a p-value of 0.002.
Oh, what? Yes. And then, which of the following best expresses the conclusion of this test uses the significance level of 0.005. Okay, so there is sufficient evidence because it's low.
Yeah.
Okay, so there's sufficient evidence to conclude the bone density of all 3 groups is about the same. There's sufficient evidence to conclude the bone density of at least one of the groups is different from the bone density of at least one of the other groups. There's sufficient evidence to conclude that bone density between all of the groups are different. B?
Yeah, that's what I was doing. We
can't tell which one.
Okay. Pressures of supply and demand act directly on the prices for an airline ticket. As the seat available on the plane begins to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount or even cancel the flight. A study is undertaken to determine if there is a difference in the mean cost of an airline ticket through the 90 days in advance of a scheduled flight compared to the price for tickets purchased only 14 days in advance. Data was collected on the cost of a one-day ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe were recorded for each scheduled flight 90 days in advance and then again 14 days in advance. The former hypothesis has determined if there is a difference in the cost of a non-stop flight with the purchase 14 days in advance compared to 90 days in advance. The level of significance of point 1. Open the data file direct flight cost. This information answers questions 22 to 26.
Okay, well, it is asking for the difference again.
So these first sentences, yeah, it's the difference. So not two pairs, right? Just zero.
Yeah, the difference in mean. Oh, how did you copy this one?
I don't copy
Oh,
them.
I knew that.
You need for this one the origins, the 14 days, and no, you don't need the origins. Yeah, no, you don't. They're all origins. Same place, 14 days and 90 days.
Okay, that makes it way simpler. So I was like, oh, if I have to do that, like.
They're so much easier.
See, now that I've like gotten the hang of SBS, like it is easier, but man, you definitely have to like.
Yeah. Yeah, I'm glad that it's the one I started with. So I'm just like, oh, okay. When I try to use it in Excel, like I went over and helped Mariella one day.
Oh, really?
And she used Excel, and I was like, I have to relearn everything.
It's just easier to close the thing than trying to delete all of it because it'll always like put question marks and then I have to go through and so it's just easier to close the entire thing and start over. Okay, then we are doing the parachute test, right? Ooh, well,
You want to bring them in two things.
yeah, you go. And what is the question asking?
What is the calculated test that you did?
Okay, so I have 1.63.
I have 1.685. That's 1.685.
Okay.
I played this
Oh,
one with multiple
which
choice.
one did you? What is it?
1.685.
What? Where are they different?
Oh, I know where they're different. So mine, maybe something in yours didn't get copied, because my
Okay.
standard deviation is 1.684.
Okay.
You copied extras. Like I only had, when I opened up, there's only 87 in each. And you assigned me an each.
Oh, that's weird. Oh, you wanna know why? Because in Excel, when you open it up, it has like extra numbers, but they're not copied. Okay.
Yeah, and then give the p-value. They should be close.
Yeah.
And 0.096.
That's my max. Oh, where's my 0.105? Is that it?
And mine's
Oh.
0.096, so they're close. And 0.105 is a split. So.
Okay. Yeah, let's go with yours then.
And then which of the following best expresses the consistent test? These level of significance of A equals 0.1.
What's your p-value?
0.096.
0.096. Okay, so it's less than. So there's
Reject. Yes. Sufficient evidence. There's no difference. True.
which there is a difference.
So let's go. Now we have to input the answers.
Okay, let's do this.
And this took so much less time than the last time.
No.
I was like, okay, we have to make sure we filled in a lot of time. Last time it took 7. Okay. Check that. Wow. Oh, look, it is perfect. Control.
I could start on mine.
Cool. I'll click start.
You're good. I attended my group meeting. Oh, just kidding. I'm here.
Are you like not really you?
I'm here, I promise.
Okay. So, question 1. Can you
Okay.
describe 90% confidence interval for mean heart rate is withdrawn and the best interest?
We are confident that the true mean of the heart rate is between 45 and 105. I swear, every time that question comes up, I'm just like, oh, no.
There's always that one thing that you're like, I'm not sure.
And you can always narrow it down between like 1 or 2, and you always choose the wrong one, so the next time you're like, I got this, but you still go with that answer.
Yep.
Okay. So researchers at the University of Mississippi want to determine whether the reaction time in seconds is go, no, go stimulus of males differs than that of females. We just randomly selected 20 females and 15 males participate. Okay, the researchers decided to construct a confidence interval to decide or determine the difference of mean is significant. They create QQ plots and both random samples. And we said the, oh gosh, we said the normal one.
Yeah,
Yeah.
it could be.
Okay.
I have them all written down. So I can remember these. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
The independent.
Yeah.
Our research is interested in estimating a savings account balance of customers at a large bank should obtain the savings account balance for simpler and 40 customers. 95% confidence interval for the mean savings account balance of the bank customers is found to be those numbers. Which of the following would produce a confidence interval with a smaller margin of error than this? That was the 90 rather than 30.
I don't know if this is 40th question, but it was copied over wrong because it doesn't say that on this one. Okay, back to your email. So it goes for ships, quality assurance, and units, toxic details, improving length of the shaft, dynamic length of the door, vertical length, and 5 samples be 1,000 millimeters, length of column observation, distribution, and deviation is 2 millimeters, calculate a 95% confidence interval, and the first one.
Yeah. Okay, to assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times. I mean, weight teams is computed. Suppose that a scale rated are normally distributed with an unknown mean and standard deviation, and I remember that one. That was the 38,000.
Yep. The mean area mu of several thousand apartments in new development is advertised to be 1,250 square feet. The tenant group thinks the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to have suspicion. The appropriate null and alternative hypothesis are the first one.
Yep. Okay. In a statistical test hypothesis, we say the data are statistically significant if p is less than the level.
Students want to determine if students in some apartments get a better grade than students in others. We collect GPAs from a non-standard sample of 17 from each of the 4 apartment buildings. Data for each apartment building is bell-shaped with no outliers. The sample standard deviation are equally equal. Can they use the ANOVA test? We said yes. Is the data bell-shaped?
Okay, to see this both, that's the same question. What did she conduct? And we said a type 1 error. Alright.
If type 1, probability of type 1 is very small, probability of type 2 increases.
Okay, okay, is this evidence that the mean nicotine content is actually higher than advertised to answer this testing hypothesis? At a 5% level of significance, you conclude that you should, what did we say?
I don't remember that. Yeah, it was 0.2. one side. You would like to look at the mean number of hours worked for wages for each students. You'd like to write a simple sample of 100 for each group and test those needs are different. What is the correct statistical procedure? And we said that it would be matched pairs. Yes.
Which is the paired.
Yes. Okay.
Okay, an educator is interested in academic achievement of males and females. Okay. She used the hypothesis test on enemies that dependent, but you have to include the subject.
Yeah. So scientists like samples. The researcher would like to construct a confidence interval. Use information of the four types of confidence interval, which is the most appropriate, and confidence interval for mu, what sigma is unknown.
Which of the following is a 95% confidence interval for these data? Which one is it?
11.168 to 15. We can. A random sample of commerce from Los Angeles and New York were taken from it. Looking at cars.com, we want to know if there are differences for the ones in Los Angeles and the ones in New York. Create a 95% confidence interval. And of the four types, what is appropriate? And we said independent samples. Right? That is what we said. Yeah.
Which of the following is a 95% confidence interval for the true difference of mean listing prices between Hummers of LA and the first one, right?
Hi. Good, how are you? Yeah. Any studies have suggested there's a link between exercise and healthy bones. Exercise stresses the bones and causes them to be stronger. Something about rats, they had to jump. And we determined that the correct hypothesis test is the ANOVA one.
Okay, and the test statistic was the 1.578.
And the p-value was 0.002. Oh, that's not actually the test statistic that I have written down.
What do you mean?
I have 7.978.
Oh, that's right. Wait, what? Oh, I was thinking of something. Oh, I was thinking the next one.
Oh, okay.
Okay. Which of the following best expresses the conclusions the test use a level of significance for 0.05 sufficient evidence that one of them is different?
Okay. They measured an airplane test and dependent sample tests or matched pairs.
Okay, calculate the certificate. That was the 1.5.
1 point. I have 1.685, but this data I still have up. This one I have up. So, yeah, 1.685.
The value is, I still have the picture. Oh, but mine was off.
Yeah, it was 0.096.
And which of the following best expresses the conclusion, and there's sufficient evidence includes error to distance and process ticket.
Okay, let's hope we did as well as I think we did.
I hate looking at it. Like, I was just
Okay.
not bad, but
No. Okay, so we said the nicotine we should have rejected, so I probably did the equation wrong. I was nervous about that one. And the wages should have been independent samples, apparently. And our Hummer wasn't wrong.
Okay. Not too shabby for me. But now that I know that you love straight A's, like
Yeah, no, it doesn't. These come up because these really don't matter. All of them together, all of the group meetings and group collaboration is 10% of the grade.
Yeah.
And all of the homework together are 10% of the grade. So I really
hate how tests are like the majority.
And we have a huge project at the end of the semester that's worth 20% of our grade. It's a group project, and I think we're gonna have to do a study, like looking at it.
I haven't even looked at it.
Well, just looking at the grades, I kind of am in love with the water concept.
Oh no, I use that all the time too. So like,
Alrighty.